Okay, welcome to this particular class where we are going to discuss the syllabus in BTech final year, right? So what we are going to do in this particular class, we are going to review the whole class. I mean, we are going to review the whole syllabus, what we are going to discuss in the coming classes. So you need to understand the concepts. Never try to by heart any subject. Try to understand the subject. When you have that comprehensive understanding, it would be very, very easy for you to gain the knowledge in that particular subject. And artificial intelligence is one of the very, very interesting subjects where you can really, as a computer engineer, you can really enjoy. So what we are going to do in this particular class is we are going to review the syllabus, what we are going to study. I'm going to share the screen for you for a moment. This is our artificial intelligence syllabus. And as our college is affiliated to Andhra University and approved by AICTE, this is the given syllabus. First, understand the course objectives, why we are actually being taught this subject called artificial intelligence. To learn about AI problem production systems and their characteristics. In the previous class, we discussed various challenges in AI and artificial intelligence mission, the artificial intelligence system. A computer, we are making the computer work as we work. We want the computer to work intelligently. We want the computer to solve my task, our tasks, by applying reasoning. So this is the idea of learning this particular subject. And the product system. So knowledge exists in the form of facts or in the form of rules. So a production system consists, the major part is production rules, how the rules are applied, okay, when the need comes, and the characteristics of a production system, and also to understand the importance of search. Search is a method when there is no direct method available. Understand, students, search is a widely used technique in computer science. And we have come across various search algorithms. Probably you would have studied number of search algorithms when you were studying data structures and similar subjects. Search is a method when there is no direct method available. Okay, search is a method that is used when there is no direct method available. See, if I tell you a phone is there on the bed in the bedroom, you directly go and you find the phone on the bed and you just get it. If I tell you phone must be somewhere in the bedroom or in the hall, then what you would do? There is no direct method. Search is the only thing. So you go to the bedroom, you search for your mobile at different locations. If you don't find, you come back to the hall and you search at different locations. And finally, if you find, you'll give the result. If you don't find, you'll end up with no result. So search is a method that is used when there is no direct method available. So we are going to study different search strategies for solving AI problems. AI problem, we use different search algorithms where we come across heuristic search. Very, very important point. That means we get some guidance. So heuristics are like tour guides. When we go to a tour, we are new to that place, then we depend on someone who can guide us. So heuristics are like the tour guides. Most probably they would lead us to the good solutions and sometimes even end up with the dead ends, but most probably they will lead us to the good solutions because tour guides always have more knowledge on that specific domain or on that specific space. And also the other objective is to study some of the advanced topics in artificial intelligence like planning, natural language processing, and expert systems. And what is expected after completing this particular course? What is the course outcome? What is expected? This is very, very important. What is expected? So students who would able to understand AI problem characteristics we are going to study different problem characteristics, because listen very carefully. Whenever you are studying a particular problem, the first very important thing is you need to understand the characteristics of that particular problem. Because before giving the solution, analysis plays very key role. As a software engineer, the development phases begin with analysis. The quality of the outcome depends on the quality of the analysis. That means you need to understand the problem first. First, define the problem properly. If you could able to define the problem properly, then there will be a possibility of ending up with good solution for that problem. See, these days, we understand in the society, many times people do not know what they actually require. Hence, they make senseless arguments sometimes. That's what we see in media. So, as a software engineer, to give a good solution to your problem, remember to give good time, to spend good time in analyzing the problem, understand the problem, define the problem properly. So, problem characteristics plays very, very important role. Then, we study production system framework, okay, that you should be able to understand how production system work, having those production rules, how the rules are applied, etc. Then also you are expected to learn different heuristic algorithms, such strategies. So even for any kind of problem, how you are going to present that problem to give a proper solution, how you are going to explore various such algorithms to find the optimal solution. And also students, you are expected to learn different knowledges. Based on the approach of the knowledge, we categorize different, we come up with different knowledges. Like we call, if you represent the knowledge in terms of tables, you call it as relational knowledge. And if you represent the knowledge in a tree structure where you can apply some object-oriented schemes, okay, then we call inheritable knowledge. Or if you could represent the knowledge in predicate logic and apply some algorithm and you could able to infer something, then you call this inferential knowledge. And if you could able to represent the knowledge in terms of program and execute the program to get the solution, that we call procedural knowledge. So these are all different knowledges. And representing the knowledge is very important. See, data is also used, right? So we store the data in the database. To retrieve the data properly, to update the data properly, we come across what is called data structures. So data structure is one of the most important subjects any computer engineer would study. Similarly, as data is to be structured mathematically, logically to retrieve it effectively, knowledge must be represented properly. So we come across various knowledge representation schemes. You need to understand how the knowledge is represented. So we come across different knowledge representation schemes. We come across predicate logic. We come across declarative knowledge. We come across procedural knowledge. We come across various intelligent programmings like Lisp and Prolog, etc. And also we come across means and analysis. We come across weak slot filler structure, strong slot filler structure, various structural representation, etc. And finally, you're expected to learn different advanced topics like how you process natural language, how planning is used, how expert systems are developed, etc. These are the different outcomes of this particular course. So after completing this course, students, you are expected to gain knowledge in these areas. So now we come to the syllabus. The first, totally, I believe there are 7 units. Okay, the first is introduction to knowledge, right? Introduction to knowledge. Already yesterday in the earlier class, we discussed some of the introductory parts. In introduction, we study about the definitions of artificial intelligence, and we study about AI problem. AI problem is not the problem what AI faces. AI problem means problems that are handled by AI system. Like say for example, you come across mundane tasks, you come across formal tasks, and you come across expert systems. What is mundane tasks? Mundane tasks are tasks that we do every day, like vision, I could able to see, speech, I could able to speak. Can my computer do that? How my computer perceive? So those are the mundane tasks. Mundane tasks are tasks that we come across in day-to-day life, everyday life. Formal tasks, like we discussed about chess game playing, mathematical theorem proving, were formulated tasks. And finally, we study about expert systems, medical diagnosis expert system, financial analyst, or any architectural expert system. You come across various expert systems. These are the different AI problems. Then we come across AI technique. What is AI technique? Listen, all of you. What is the AI technique? See, AI technique is how you solve these problems. What are the challenges? See, it's not an easy thing because knowledge is huge. Handling that knowledge is a big problem. How to handle that big knowledge? Because using that knowledge is solving the problem, but handling that knowledge is another problem. So that we come across AI technique. Then defining the problem as a state space. Given the problem to solve in AI, first you represent the problem as a state space such problem. Where you'll have initial state, you'll have a goal state, you'll have intermediate states, you'll define the problem space, and you need set of rules to move from the initial state to the final state. That's it. That approach is called state space search or state space representation. You need to represent the AI problem as a state space problem, a state space search problem. You should have an initial state and you should have a final state. Where you start is the initial state, where you find the solution is the goal state. Now the task is moving from the initial state to the goal state. That's it. Now, then we come across various problem characteristics. Just now we discussed about problem characteristics. There are 7 different characteristics that are mentioned in Rich and Knight Artificial Intelligence textbook. So we study those 7 characteristics. Very, very, very interesting. Then we come across production system. I told you components of the production system we are going to study. And also we are going to study about various types of production systems, like monotonic production system, non-monotonic production system, partially competitive, fully competitive production system. Likewise, we study about different production systems. Okay. Then in the second unit, we come across different search techniques. We know basic search algorithm like breadth first search, depth first search, etc. But here we explore heuristic search algorithms. Heuristic search, where we use heuristic function, usually represented in numbers. Say, for example, I am at node S, starting node. I need to make a decision now whether to go to A, B, or C. So which node to be selected first? Say, for example, I have some distance like 1, 2, 3. So distance 1 is near. So that one is called heuristic function. So I will choose A because from S, A is just 1 as a quantifier. 1 is the distance. So 1 is lesser than 2 and 3. So I opt A. So I have some guidance to move. So those are called heuristic. Then we study about different heuristic search algorithms, starting with the fundamental search algorithm, like we call it as blind search, generate and test. Generate and test. Generate a possible solution, test if it's the required solution. If it is the required solution, give it and leave. If it is not the given needed solution, then generate another solution. It's like a blind man searching for the coins from the pocket. Otherwise, we even search the coins from the pocket. If you want to give 1 rupee 50 paisa, then we take one coin. If it is 1 rupee, we keep it with one hand and we'll try for another coin. We try for 50 paisa, then we pick up one coin. If we find 1 rupee, then we leave it. Again, we'll try till we get 50 paisa. Then we get the total solution. Something like we use generate and test algorithm. Then we use hill climbing. We come across hill climbing search algorithm. Hill climbing, we study two variations. One is simple hill climbing, one is steepest hill climbing. Then we study about some problems in hill climbing, because hill climbing is one-way direction. Once you opt a solution, you cannot come back even though you understand there is a better solution. So hill climbing ends up with some limitations. Then we study best first search algorithm. Okay, so best first search algorithm better than the remaining search algorithms. There we study two variations. One is A star algorithm, one is called AO star algorithm. Those are the very important algorithms we study about. Not just exploring trees, we try to explore graph structure, where we find loops, how to search a graph for an optimal solution. So we study A star algorithm, AO star algorithm in best search algorithm. Then we come across problem reduction or AND OR graphs. So far, you know OR graphs. From yes, you can go either A, B, or C. Now we introduce an AND OR. If there is an arc to this A and B, you need to solve A and also B to get the complete solution. So we study about AND OR graphs. That is also called problem reduction. Of course, there we study AO star algorithm. Then we come across constraint satisfaction algorithm. Constraint satisfaction is, say, I told you initial state and the final state. In constraint satisfaction, where initial state will be the problem description, final state will be the state where the given constraint is satisfied. Then it need not be a specific state. It can be any state, but my given constraint must be satisfied. That's the solution. There we use an example of cryptarithmetic problem. Okay, cryptarithmetic problem, we will study what it is actually. Then we study means and analysis algorithm, where we see the problem as the gap between initial state and the final state, where we solve the major problems first, then come back and solve the little concerns or little problems or less challenging problems. And in means and analysis, we see the problem as the gap between the initial state and the goal state. If there is no gap, solution is found. So there ends the second chapter. Then we study about the third unit, knowledge representation using rules. But somehow it must be swapped. Third and fourth chapters. Better you keep the fourth chapter in the place of third chapter, and you keep fourth chapter in the place of third chapter, and vice versa. So then we study about knowledge representation. See, problem, search, knowledge representation, then advanced topics. That's how we study. See, knowledge representation, we need to come across, we will study knowledge representation issues, though they are not in your syllabus, but I'm surprised by finding out the outcome is to learn different approaches of knowledges. Different approaches of knowledges, you need to study knowledge representation issues. So though they are not present in the syllabus, we study knowledge representation issues, then knowledge representation schemes, starting with predicate logic, propositional logic, predicate logic. In predicate logic, how we learn how to represent a statement in the form of WFF, well-formed formula. Well-formed formula using two quantifiers, like existential quantifier, there exists an universal quantifier for all. And we try to represent an English statement into a well-formed formula. Then we convert them into class forms, a statement that can be used for different algorithms like resolution algorithms. We come across unification algorithms that we study in predicate logic, first order predicate logic. Then we go to the third chapter. That means after fourth chapter, we go to the third chapter. various types of knowledges. There we study about two different knowledges. One is declarative knowledge, one is procedural knowledge. Declarative knowledge is specified, but the way the knowledge is to be put is not given. How to use the knowledge not given. It is declarative. The knowledge is declared. So again, you need an inference engine. You need some algorithm to use this particular knowledge. Whereas procedural knowledge, the knowledge itself is a program. It's a logic programming, prologue, programming with logic. So where we study about procedural knowledge, where we study about matching is which rule to be used at this particular state, that rule should be matched. Where we study about one-to-one matching, one-to-many matching, we study about REAT algorithm, variable matching, etc., approximate matching, etc., that we come across in matching, right? So there we complete symbolic logic and knowledge representation using rules, etc. Then we come across reasoning with under uncertainty. See, if the knowledge is certain, okay, it's very easy. See, in the beginning of this class, I was discussing about a dynamic knowledge, where a system needs knowledge on the real time. Which party is going to win in the upcoming elections? If it is in USA, say USA elections are approaching actually, there are only two parties, Republic, Democratic. Which party is going to win? It's a huge task where the knowledge is very uncertain. You cannot give a predictable facts. You can predict it, but prediction can never be 100% true because it is just a prediction. So how to handle such kind of situations? There we study the reasoning, how to reason and come to conclusion under uncertainty. There we study about non-monotonic reasoning, truth maintenance systems, and logics for non-monotonic reasoning. Then we study about statistical reasoning, how to quantify the uncertainty. See, sometimes you say, I'll come. Instead of saying, I will come, you say, 90% I will come. That means 10% you are not going to come. So how would I take? Will you come or you are not coming? Handling that uncertainty is very difficult because you said 90% I will come. So I cannot take you're coming for granted, you're not coming also for granted. So 10% you kept me in uncertainty, how to handle it. That we study under statistical reasoning. There we study Bayes' theorem, and we study about certainty factors and rule-based systems, right? And Damster-Sefri theory, and also we study a little about fuzzy logic. These are all how to handle uncertainty. Then the 7th unit is relatively simple, natural language processing. You studied already, I believe in 3rd year, you studied formal language and automata theory, flat, or theory of computation. There you must have studied about this processing, context-free language, context-sensitive language, context-free language. There you study how to process these production rules. Similarly, we studied language, natural language processing. What are the steps in natural language processing? Systematic processing, right? Augmented transition nets and semantic analysis.
Excuse me, sir.
Yes.
Sir, ఒకసారి syllabus sheet share చేయరా?
You don't have those syllabus sheet with you. I'm surprised. You don't have syllabus sheets with you. See, we are in the 6th unit, right? Right, NLP. Then we study, though not as a separate unit, planning is another chapter. Planning is not the original planning what we do in day-to-day life. That is not planning here. Planning is divide and conquer approach. Divide the major problem into sub-problems, solve the sub-problems, combine the solutions of the sub-problems, then you'll end up with the complete solution. So there you study about different concepts like what is called goal stack planning, linear planning and non-linear planning, solving the sub-problems parallelly or one after the other, then hierarchical planning, etc. we study. And finally, we study about expert systems. Expert systems. The major part is the components, the architecture of an expert system. Then we study about different types of expert systems. Like some expert systems are rule-based expert systems, some are frame-based, some are decision tree-based, case-based, neural network-based, blackboard architectures, and knowledge acquisition and validation techniques, etc., etc. Because expert systems should gain the knowledge from not just from the database, from the real-time environment. So this is about artificial intelligence, the syllabus overview, and the major textbook what we use is Ellen Rich and Kevin Knight and Tata McGraw-Hill publications. Excellent system. Of course, in the recent edition, even one Indian author also contributed. And also you can study Introduction to Artificial Intelligence and Expert Systems by Peterson, okay, PHA publications. And there are some reference books, but major textbook we use Ellen Rich and Kevin Knight. So this is about the whole syllabus, right? Whole syllabus in artificial intelligence classes, what we are going to handle in the next few weeks. Thank you.